Hello everyone, welcome to Lex Learn YT. So myself Shashivardhan from NLI Bhopal, and in part 1 we learned the fraction to percentage table. If you didn't see it, go back. And now we are going to do some word problems. CLAT doesn't care if you can multiply. It cares if you know who the base is. So now let's do the first question. Rahul's score is 25% more than Anjali's. By what percent is Anjali's score less than Rahul's? So now let's assume the base as 100. So if Anjali has got 100, means Rahul's score is 25% more. It's nothing but 125. The gap means the difference between 125 and 100 is 25. But the base is now Rahul, which means it's 125. So 25 by 125 into 100. It means 25, 1 by 5 into 100. 1 5 20, and we know that it's 20%. So now the second question. Two numbers are 20% and 50% more than a third number. What percent is the first of the second? So if you want, you can read it once again. Now let's move to the answer. And here set the third number as 100. It's easy to do problems when you assume the base as 100. So now the first number is 20% more, means 120, and the second number 50% more than the third number is 150. So now what percent is the first of the second? First of the second. So now 120 by 150. First of the second means second becomes the base. So 120 by 150, which means 4 by 5. And in the previous problem, as we know, 1 by 5 is 20%. As we learned from part 1, the percentage table, 4 by 5 means 1 by 5 into 4. It means 20% into 4, it's nothing but 80%. So now the third question. A student multiplies by 3 by 5 instead of 5 by 3. What is the error percentage? So now let's go with the logic. Now pick a common multiple of 5 and 3. It's 15, right? A common multiple of 3 and 5. So the correct answer is 25 and the wrong answer is 9. So how I calculated it? It's nothing. So a student multiplies by 3 by 5 instead of 5 by 3. So we have to assume that number as 15, and he multiplied by 3 by 5 means 3 by 5 into 15. 5 ones 5 threes, and 3 by 3 into 3 is 9. So it's the wrong answer instead of 5 by 3. So 5 by 3 is the correct answer. When 5 by 3 is multiplied by 15, we get 25. So the correct answer is 25 and the wrong answer is 9. So now we have to get the difference between the correct answer and the wrong answer. It's 25 minus 16, which is 9. Pardon me, it's a mistake. So 25 minus 9, it's 16. So now 16 and 25 is the base now, into 100. 25 ones 4, 16 4, 64%, and the error percent is 64. This is where 90% of students take the pardon me. This is where the 90% of the students take the wrong question. You cannot just add percentages. Maths isn't that nice. You have to calculate them one by one. So, here the question is a person gets a 20% salary hike in year 1 and a 10% hike in year 2. What is the total hike? So, now let's move to the logic. Some of you will say 30%. No, it's not 30%. So, let's assume his salary is 100 and it gets a 20% hike in year 1 means plus 20%. It means 120 and 10% in the second year. It means plus 10%. What is 10%? 120 of 120. It's 12. So we have to add 120 plus 12. It's nothing but 132. So here the result is it increased the 32%. We can use the short form, which is A plus B plus AB by 100, which I told in the part 1. It's nothing but 20 plus 10 plus 2. It's 32. Now moving on to the next question. A mega sale offers 20% plus 10% off. What is the total discount? So now let's find the answer by using the logic. A mega sale offers a 20% plus 10% off. So now let's assume a product which is like 100 and it offers a 20% first. It means minus 20%, which is 80, and minus 10% means what is 10% of 80? It's 8, right? So we have to subtract 80 from 8, which is 72. So now let's get to the result, which is 100 minus 72. It's nothing but 28%. See, it's a marketing trick that is used everywhere in the world. It's some people blindly believe that it's 30% off. No, it's just 28%. So now moving on to the next question. Population increases by 20% and then decreases by 20%. So what is the net change? So there's a rule that was taught by my teacher. It's called the square rule. Means here it's the same up and the same down. Means it increases by 20% and it decreases by 20%. So now we have a formula for that. It's nothing but x square by 100. When we use this formula, we have to know that it's always a loss or decrease. So now we have to assume that, so we know that the x is 20. So 20 square by 100, 400 by 100. It's nothing but 4. So it means that it has decreased 4%. So here comes the next question. So let's take a product. Its price is increased by 25% and then down by 20%. So what is the net change? So now let's go with the logic. And we have to assume the price of the product as 100. Now as we increased it 25%, it's 125 and the price has become 125 and then down by 20%. What is 20% of 125? It's 25. So now we have to subtract 25. It means 100. See the initial and the final price. So now the result, it's a 0% change because the values are same. So now moving on to the next question. So someone's income is up by 20% and expenditure is also up by 10%. So he gave the original expenditure is 80%. Find the percentage increase in savings. So if his original salary is 100 and the original expenditure is 80%, means it's 80, and the original savings were 20. And as the new salary, it's his income is up by 20%, which is 120, and his new expenditure is also up by 10%. What is 10% of 80? It's 8. So we have to add 8. It's 88. So now savings, new savings is 32. Means it nothing but salary, new income minus new expenditure. It's nothing but 120 minus 88, which goes back to 32. So now the result, it's 12 by 20, which is a 60% increase, as 32 minus 20 is 12 and the original savings were 20. So now it's 60% increase. And if you want to know how I did this solve, it's nothing but 12 by 20, 2 6 and 2 tenths, 2 3s, 2 5s, 3 by 5, 3 by 5, and 1 by 5 into 3, 20% into 3, which points me back to 60%. So you have to learn the percentage table for this. So these are some medium level word problems. If you can vibe with these, you aren't just good at math, you are above average, you are like the main character, you're spotting the traps before the examiner even sets them. In part 3 we take these logic chains and apply them to a massive data interpretation case.